Hey, howdy friends. This is section 3.2. Okay, section 3.2. Again, this is pretty heavy with some vocab, so I'm going to get my highlighter ready because this is talking about, again, a section. We're still dealing with linear equations, and so we're looking at the ways that functions can be represented, and we're going to look at, oh, that was a vocab term. We're going to look at functions. We're going to look at linear, non-linear. We're also going to look at our domains again, and whether they are discrete or continuous. Okay, so I'm going to do a whole lot of highlighting here because all of these will be technically vocab terms. Okay, so here we go. So if we understand what functions are from section 3.1, then this section will not be very hard. So let's look at this. So let's do this function. Oh, I said a vocab word. And I'm going to put it in words. And output is 3 more than the input. Oh, wow. I don't know if we used input and output as terms, but I know we did function. But could you tell me the output was Y and the input was X? So the equation would be Y is 3 plus X or X plus 3. Okay, the output is 3 more. So whatever this is, the output is 3 more. I know that looks really weird. Let's look at this as a table, okay? As a table of X and Y, or input, output, okay? And let's look at this. So I don't know, let's try -1. So if -1 is X, so this would be -1 plus 3 would give me 2. Okay, how about 0? That's 0 plus 3, that would give me 3. Do you see a trend? All right, 1 plus 3 is 4, and 2 plus 3 is 5. Awesome. Okay, I could say, I can put this as a map as well. And that's where we were using those circles, okay? So I could use -1, 0, 1, and 2, and that went to 2, 3, 4, and 5, and you just draw, okay? And the last piece, you could do a graph, couldn't you? Now I do have graph paper, but I think we'll be all right. Okay, so let's graph. Let's see, -1, 2, 0, 3, 1, 4, and 2, 5. And I can go ahead and I can connect these because there was no necessarily stopping, okay? So this would be a graph of this. So that is one way to describe one equation, okay? Now, this is a straight line, isn't it? So we're going to introduce, this would be the term linear. So linear means a straight line, okay? So any sort of straight line, it can't be a curved line, okay? That's all there is to it. okay? And the other piece to, so we've talked about linear, non-linear. Let's see. Let's do this, okay? Whoa. So I just wrote the equation for you. This is -3/4 of x cubed. So is this linear or non-linear? And then we're going to go ahead, we're going to graph it too. Okay. Well, if we don't know, one of the ways that I would do is I would do a table of in and out. Okay. So the first thing I would do is I would just I'd just start with some easy points and maybe 0, 1, and 2 and see where I've got to go from there. So let's see, 0, that would be -3/4, 0 cubed. Well, that's just 0. Okay, and I'm also going to come over here and I want to draw a graph. So I want to see what this looks like. Okay, so 0, 0. All right, let's try 1. -3/4, 1 cubed. Well, that's -3/4. So 1 and -3/4. Okay, let's see. And let's do 2. Yikes. -3/4, 2 cubed. Ooh, 2 cubed is what? 2 times 2 times 2, that's 8, times -3/4, that's -6, I believe. Let me just do the quick math in my head. -3/4, that'd be, yep, -6. So 2, 1, 2, 3, 4, 5, 6. Oh, wow. That's like doing this. Does that look like a straight line to you? That is totally. And in fact, with linear, it needs to go up on a regular basis, like a stair step. So this is totally non-linear. Yeah, that is not. In fact, what piece do you think you can point out that's given away the non-linear part? You're right. It's that cubed. Linear means we want x just to the first power. See? X. See that little 1? No, you don't see it? That's because we don't write it. Right, it's x to the first. So we want linear to mean x. It's got to be at the top. It can't be at the bottom. It's got to be all by itself, just like that. Okay, once you have something that is linear, then we want to look at, find the domain and whether or not it is discrete or continuous. So discrete versus continuous. Okay. And really what you're going to see here, it would be very similar to looking at a number line. Okay. I want this dot, and this dot. Do I want anything in between? No. Versus continuous, which means I want everything in between here. Okay. So you just put that on a graph. It's the same things. I want all numbers between 1 and 3. This I want 1, 2, 3. Think about this. Discrete. Can I have half? Okay, so the reason I said this is because sometimes we deal with story problems. So like the number of hot dogs I can buy. So literally, can you buy half a hot dog? You can't. But can you buy half a gallon of gas? Yes, yes, you can. So be careful, because then we can kind of point out whether we should be hitting certain dots or a whole bunch. So the first thing I'm gonna do is I'm gonna show you, I'm also gonna link this to you. I wanna go through this for extra practice, okay? So I'm gonna link this page, a blank page, and you can do this with me if you want. So in exercise 1 and 2, determine whether the graph represents linear or nonlinear. Is this a straight line? No, silly teacher. How about this? Is this a straight line? Yes. Okay, now as a table, does this, so you know how we went up on a regular basis, okay? Does this go up on a regular basis? Let's see. This goes up by 1. Whoops, how about I actually get it? 1, 1. How about this? This goes up by what? So 1, 2, 3. This goes up by 3. This goes up by 3. That happens on a regular basis. So yes, this is linear. If we were to graph this, okay, 1, -1, 2, 2, 3, 5, okay, it would form a straight line. Absolutely. How about this? I'm going up by 1, up by 1, up by 1, +1, +1, +1. How about this? Down by 1, oh, up 1, up 3. Oh, no, 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 no. That is not linear. Okay? Okay, let's see. Now, remember, this one we said was nonlinear. I gave you that example on your notes. How about this one? Look at this x. Is this x all by itself? Is it to the first power? It looks like it. Could you come up with some points and do a test real quick? Okay, could you do that? Or could you come up with an XY table to see if it climbed on a regular basis? Well, sure, let's do this. Let's plug in 0. So what's 3 minus 2 times 0? Well, that's 3. And what's 3 minus 2 times 1? Well, 3 times 2 times, that'd be 1. So it's going down by 2's. Let's see. So this one should be a -1. Let's try it. 3 times 2 times 2, that is a -1. Check. That is linear. Be careful, because maybe your graph doesn't look so good and you don't want like your makeshift graph. But that doesn't look so bad, does it? All right, is this discrete or continuous? See how it's a continuous line? Yep. See how this is dot, dot, dot? This is discrete because my domain, so let's talk about this. So let's write it. My domain values here. How do I write that I want everything between 1 and 5? Well, I write that. I want everything between 1 and 5. Did you see that? Less than 5 and greater than. And notice, I don't care about the range. I just want, the domain. Okay, so this we've got to practice writing. That's the hardest. All right, what's my domain values here? Well, this is easy. So what's x here? Well, x is 1, x is 2, and x is 3. I just want the x values, okay? And that's it. I can buy 1, 2, or 3 hot dogs. All right, that's it. Thanks, friends.